Did your teacher just teach you about ambiguous case triangles and you are feeling all ambiguous about it? Yeah, I get that. Let's clear up any confusion you have on these triangles so that way you can spot them a mile away. My name's Danielle. I'm a high school math teacher and I love sharing strategies on how to learn math with ease, plus sharing math questions with you so you have support outside the math classroom. I have a download for this lesson so that way you can use my 3-point check for ambiguous triangle and know exactly when you're dealing with one and never have to think too much about it. The download link is below, so be sure to download and print so you can follow along with me. All right, the first thing we have to do is identify ambiguous case triangles. In this lesson, I am not going to show you examples of solving them. I just want to get down the 3-point check system that you need in order to know, hey, I have an ambiguous case triangle in front of me. So the first thing is knowing how to red flag them. I tell my students the first checkpoint is recognizing if your triangle is a side A or side angle, triangle where angle A is acute. So I have a diagram here and we have, let me just find my pen here. We have side A, side B, and angle A. So side angle, and this angle here is acute, meaning it's less than 90 degrees. If that's happening, you've got one checkpoint to possibly having an ambiguous case triangle. The second thing you're going to check for is that the side length A is less than the side length B. Now, side length A is always the one that I'm talking about is always going to be across the given angle. So you always want to check the side that corresponds to the angle. Is that side less than the other side given? If so, you have confirmed that checkpoint 2 is there. So again, we might have ambiguous case on our hand. The next part, this is the difficult part, is knowing how many triangles you have. So you could either have one triangle, two triangles, or no triangles. And I want you to think of this, if we had 3 toothpicks or sticks in front of us, and I told you the measurements, I gave you a side length and an angle, you would be playing with it to see if you can actually form that triangle. Now, to make it easier on ourselves, we could just look at the height of the triangle and figure this out. So how do we do that? We are going to take the height, and just to go over this, the height is from the vertex of one vertex of the triangle going down perpendicular to its opposite side. That's the height of a triangle. And it doesn't matter which vertex we go from, but you will get the height of the triangle either way. So what I want you to consider right now is what could happen, okay, if we have ambiguous case. Let's pretend, and I'm just going to finish drawing this right now as a full triangle. And imagine these two are connecting, okay? My math art isn't that great, but we have a side length, and an angle. So checkpoint 1 has been hit. I feel like I'm playing Battleship right now. Then Battleship sunk. So then if side A, now I'm going to call this triangle, look, A is already here. I'm going to call this B, and I'm going to call this C. Little a, and this is going to be little b. So side, actually, let's write this down. Side angle, check. Is little a less than little b? Yes. So now what I'm looking for is, could I possibly make a second triangle? I see the first one here, but could I take this side A and rotate it? So imagine this arm swinging over, it's going to rotate to here, such that you get the same length. That's a funny line, but you get the same length. It's A, size A, or length A, 5.9. I'm going to call it A prime, just to show you that I've rotated it. And it still makes a triangle, and nothing has changed with the given information. The 5.9 has not changed, the 7.8 has not changed, and the 36 has not changed. This is an example of ambiguous case when two triangles could appear. So like I said, we're going to use height of the triangle to figure out if this could actually happen. That's going to be our third checkpoint. So let's come down here and see how this actually works with height. Okay, so you've checked side A, you've checked A is less than B, and now you're exploring the height of the triangle. So in this diagram, we see the dotted line is height, and we want to see, is height less than A? If height is less than A, you're going to have two triangles. That's ambiguous case, okay? Now, how can we find the height of this triangle? I'm going to redraw this triangle, okay? And I'm going to just draw it with the height because I have too many lines in here. I don't want it to be confusing. So this is the height line. And let's just imagine that this is an angle A, okay? This is height, it's 90 degrees, and this is little b. We know that if we have this angle, because it's given to us, we could do sine of A is equal to opposite height all over B, which is given to us, hypotenuse. This is our hypotenuse. So what we can do then is solve for H. We can say that cross multiplying this over will give us B sine A. So our height, if we isolate it, is B times sine A. Once height, you can then compare it to A. So if height is less than A, then that means height, which is this as well, B sine A, whoops, I forgot the I, will be less than A. So if B sine A is less than A, you have two triangles. You have ambiguous case, and you're going to have to solve both of them. All right. If your height, so let's say you do this calculation, B sine A, you figure out what B sine A is, and it's equal to A. That means you just have one triangle. Okay, and that's this scenario here. If your H is bigger than A, look at this H being bigger than A, and I rotate A, there's nowhere I could rotate A and close that triangle off. So if B sine A is greater than A, no triangles exist. Now, what's probably most confusing for students is they are given information like this and told, are there two triangles? Is this ambiguous case? I'm going to show you right now a little trick on how I handle this. I love to set up my triangles always like this, A, B, and A. So I can always use my 3-point check system and use less mind time to check for ambiguous case. So I'll show you what I mean. Okay, let's pretend they're telling us A is equal to 5. So that's side length. A is equal to 5, B is equal to 3, and angle B is 62. I'm going to randomly draw this triangle as if you were going to see it in a textbook. Okay, I don't know, like this. It doesn't matter how I draw it, right? And let's say that this is A, it equals 5. This is B, it equals 3. And the opposite angle, big angle B, is 62. This does not look like anything I had in the beginning of this lesson where that triangle had, it was more like this, right? Whoops, sorry. Again, my math art is not great. I want it like this. I want the angle here. So let's put it here, 62. And the side that goes with it is 3. And the 5, where does the 5 go? Remember, it's right beside the 62 and connecting to the 3. So that's going to be here. Now I have side, angle, just like I did up above. So check 1. Let's now check is side A. And notice this is really angle B, but I labeled it A for myself because I want to use all the checkpoints as I was taught. So side A, which is this guy, 3, is it less than B, which is here, right? And I'm making this big B. Again, I know in the question it says B is 62, but I'm rearranging this so it makes sense to me. Now, is is side A 3 less than B 5? Yes, check 3. Okay, now we have to check the height of the triangle. So I'm going to change colors for a second. Give me a second. I'm going to redraw this down here. So I want to see, is H less than A, or is it greater than A, or whatever have you? Because remember what we set up here. If H is less than A, we have two triangles. So let's check, okay? If I'm drawing this out, or I'm saying sine A is equal to opposite H, whoops, that's not an H, opposite H all over hypotenuse B, I'm checking if H, which is B sine A, is less than A. So I'm checking for B sine A is less than A. Okay, let's calculate this. What's B? B is 5. Sine of A, angle A is 62. I need my calculator. Hold on. Okay, I'm just punching this into my calculator. I'm checking I'm in degree mode on my calculator. So 5 sine 62 is 4. Ooh, what is it? 4. What are you guys getting? 4.41. So is 4.41 less than A? What is what? Oh, look at that. It's not less than A. No, it's greater than A. What scenario are we dealing with? If we are greater than A, we have no triangle. So that's what we would say here. Therefore, no triangles. Oh, I love this lesson. I never understood this in high school, you guys. Never. So there you have it. Now you know how to red flag ambiguous case triangles. If you're interested in any of my math prep courses, I'll leave the link down below. You can also take my quiz so you can discover your natural math strengths and how to use them to level up your math marks. I have a free workshop that goes with it too. If you have any questions about ambiguous case, definitely leave them down below. I'll see you guys in the next video.